In this video, we will discuss about transfer function from state space model. We know the state space model of a linear time invariant system is x dot is equal to ax plus bu and y is equal to cx plus du. So basically the state space model is represented by two equations. This is the state equation and y is equal to cx plus du is the output equation. This is the output equation. In this equation, u is a input, okay, x is a state variable, y is a output, and a here is a is a system matrix. 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 And B is a input matrix. B is input matrix. C is output matrix. C is output matrix. And capital D is a transmission matrix. Transmission matrix. Transmission matrix. Okay, now to find the transfer function, we will apply the Laplace transform on both sides of the state equation, that is this equation, x dot is equal to ax plus bu. So x dot is nothing but here differentiating x with respect to t one time. So the Laplace transform here we have assumed that initial conditions are 0. So its Laplace transform is Sx of s is equal to Laplace transform of x is x of s. It is x of t, so its Laplace transform is x of s. Similarly, the Laplace transform of an input u of t is u of s. So we'll take this x of s on this side and we can take x of s common. So if we take x of s common, the remaining term will be si minus a, where I is unit matrix, or it is also called as a identity matrix. Unit matrix or the identity matrix. So from this we can write x of s is equal to si minus a inverse into b into u of s. Here this si minus a inverse is nothing but, in matrix we find the inverse of any matrix is, so here I will write si minus A inverse is equal to adjoint of Si minus A, adjoint of Si minus A minus A divided by its determinant of Si minus A. Okay, so this is a formula. From this we can find out inverse of a matrix. Now similarly, we will take a Laplace transform on both sides of the output equation also. That gives us y of s is equal to, this was our output equation, y is equal to cx plus du. So if we take a Laplace transform on both sides, the Laplace transform of y of t is y of s, x is x of s, and u is u of s. Okay, now here once you have found the Laplace transform of an output equation, we will substitute the value of x of s here. So what is our x of s is? It is Si minus A inverse into B into u of s. So here I have substituted the value of x of s, that is Si minus A inverse into B plus u of s. So plus d into u of s, this term will remain as it is. Now you can take u of s common here. So if we take u of s common, the remaining term is c into Si minus A inverse into B plus d. So the transfer function is the ratio of Laplace transform of an output to the Laplace transform of an input. So output to input ratio is nothing but a Laplace transform here. So we got the expression for the Laplace for the transfer function as c into Si minus A inverse into B plus d. So this equation represents the transfer function of the system. So using this formula, you can calculate the transfer function of an system. Now suppose in case if the value of d is equal to 0, if d is 0, then in that case the expression for the transfer function is like this. So this is the expression for the transfer function when the value of d is equal to 0. This is the expression. This is applicable when the value of d is 0. So let me take one example. Here the question is calculate the transfer function of the system represented in the state space model. That means here two equations are given. One is a state equation and another one is a output equation. So this is nothing but if you compare this equation with a standard equation, that is ax plus bu, we have written x dot is equal to ax plus bu, and we have written y is equal to cx plus du. These are the standard equations of a state space model. So if you compare this equation with this equation, we can say that the matrix A here is the matrix A here is nothing but it is this one. This is matrix A. So here it is written as A is equal to minus 1, minus 1, 1, 0. Similarly, the matrix B is 1, 0 and the matrix C is 0, 1. So D is 0 here because there is no D present here. So the matrix D is equal to 0. As we have already seen the formula, if the value of D is 0, the transfer function is given by the expression y of s by u of s is equal to c into si minus a inverse into b. Now what we'll do is we will substitute the a, b and c matrices in the above equation. So here si minus a is s multiplied by I. As I told, I is a unit matrix, so that unit matrix is 1, 0, 0, 1, 2 by 2 matrix minus A. So what is my A is minus A. My A is, we have found the value of A as minus 1, minus 1, 1, 0. So let me write the value of A here, minus 1, minus 1, 1, 0. This is the A. Multiply this S inside this, multiply S with the matrix. So I will get the matrix as S0, 0, S. And then what you need to do after the multiplication, subtract it with the matrix A. That is minus 1, minus 1, 1, 0. Okay. So the resultant matrix will be equal to, if you can see, S minus of minus 1, which is S plus 1. Okay. So 0 minus of minus 1, which is plus 1. 0 minus 1, which is minus 1. And S minus 0 is S. So you need to find inverse of this matrix. So inverse of matrix is, as we have already seen, it is equal to adjoint of a matrix, adjoint divided by the determinant, So here the adjoint of a 2 by 2 matrix is, you need to interchange these two values. So that is what written here, S is written here and S plus 1, and change the signs of these two diagonal elements. So they will become this plus 1 and here minus 1. And then what you do, find the determinant. S is multiplied with S plus 1 minus 1 into minus 1. So this is the determinant. Now you need to multiply this matrix with this matrix. So this matrix is a 2 by 2 matrix, and this one is 2 by 1. So the resultant matrix will be 2 by 1, multiply row into column. So S into 1 is S, so minus 1 into 0 is 0. So here you will get S. 1 into 1 is 1 plus S plus 1 into 0, that will be 1. So similarly you multiply 0, 1 with S1. Okay, and simplify this one, you will get the transfer function as 1 divided by S square plus S plus 1, because here 0 into S is 0 plus 1 into 1 is 1, because the size of this matrix is 1 by 2 and this one is 2 by 1, you will get 1 by 1 matrix. Size of the matrix is 1 by 1. Okay, thank you.